In this video, we are going to talk about minors and cofactors of a determinant. Minors and cofactors are very important terms in a determinant. You need to understand the concept of minors and cofactor to learn about the inverse of matrix, adjoint of matrix, and even to calculate the determinant of higher order matrices too. Now, here you can see I have taken a 3 by 3 matrix, determinant of 3 by 3 matrix. So the order of this determinant is 3. Now, let's talk about minor. What is a minor? A minor of a determinant is also a determinant, but is of one order lower than that of that original determinant. Each element in this determinant has its own minor. Understand? Since this determinant has 9 elements in it, so it will also have 9 minors corresponding to each element. Now, how do you find the minor of each element of this determinant? What will be the minor of this element? To calculate the minor of this element, you cancel out this row and you cancel out this column. And those elements which remain, that will give the minor of this first element 1. So what will be the minor of element 1? We represent the minor of element 1 with m 1 1 because we represent minor with m and 1 1 represents 1th row and 1th column element. This 1 1 represents the position of the element whose minor is to be determined. So m11 will be equal to determinant of 2 1 5 and 2. Here 2 1 5 2. After cancelling out this row and this column, the elements which remain are 2 1 5 and 2. So minor of this first element will be denoted by m11 and will be equal to determinant of 2 1 5 and 2. Now we can calculate minor of each and every elements in this determinant. So what will be the minor of this 5 here? To calculate its minor, you just cancel out this row and this column, and the remaining elements will give the minor of that element. So what will be it? It will be m. It is third row and second column element 3 2. m32 will be equal to 1 5 7 and 1. Now you can easily calculate the determinant of this, which will be equal to 1 minus 7 times 5, and it will be equal to minus 34. So this is minor. I hope you have understood the concept of minor. Let's talk about cofactor now. After you have understood the concept of minor, you can easily understand cofactor also. Cofactor is just signed minor. Cofactor is also a minor, but it will have positive or negative sign in it based on the position of the element whose cofactor is determined here, and it is denoted by a, capital A. It is denoted by capital A. And if we are willing to calculate the cofactor of this first element 1, what is its position? Its position is first row and first column, so 1 1. So the cofactor of this 1 will be represented by A11, capital A11. Minor was represented by M11, and it was equal to 2152. Now cofactor is also minor, so it will also be 2152, but the difference is it will have positive or negative sign based on the position of this one, based on the position of this element. So if the sum of the row and the column, or sum of the position of row and the column of this element is even, then it will have positive sign, and if it is odd, then it will have negative sign. So you see here It is at first row and first column. So what will be the sum of this 1 and 1? It will be 2. Since it is even, it will have positive sign. And now, what will be the cofactor of second element now? First, let's find the minor of second element. For the second element, we cancel out this, the row in which it belongs and the column in which it belongs. Then, what will be the minor? Minor will be represented by m, and it is first row and second column element. M12 equals to, it will be 7, 1, 3, and 2. So now what will be the cofactor? Cofactor is represented by a. So a12 is also equal to minor, but it will have positive or negative sign based on its position. It is also the determinant of 7132, but so 1 plus 2 is equal to 3, which is odd, so it will have negative sign. So what will be the formula for a cofactor? Can I write a ij equals to -1 power I plus j times mij? Aij equals to -1 to the power I plus j times mij. What does it mean? It means the cofactor is just signed minor, which I have already told you before. Here you can see aij equals to mij, but it will have positive or negative sign. This -1 to the power I plus j gives positive or negative sign. Here, if the element is, let's talk about this m12, this second element. It is at first row and second column, so it is 1, 2. So I equals to 1 and j equals to 2. What will be the value of I plus j? 1 plus 2, which is equal to 3. So -1 to the power 3. What will be the value of -1 to the power 3? -1 to the power 3 means you multiply -1 through 3 times. So -1 times -1 times -1. It will be equal to -1. So it will give negative sign for this first element or this third element. It is its position is first row, third column. So 1 plus 3, which will be even. So -1 to the power 4. 1 plus 3 is equal to 4. So -1 to the power 4. It will be positive. So cofactor is just minor with positive or negative sign based on their position. So now we can find out the minor and cofactor of each and every element of this determinant. Here, what will be the sign of every cofactor of every element? Here, for first element, it was positive. So for in 3 by 3 matrix, I am going to show you the sign of cofactor of every element of 3 by 3 matrix. This is going to be positive because it is first row and first column, and 1 plus 1 is equal to 2, which is even. So it will be positive. Then it is going to be negative. Then it is going to be positive. And then what is it? This is second row and first column. So 2 plus 1, which is 3, odd. So it is going to be negative. Then this is going to be positive. This is going to be negative. This is going to be positive. This is going to be negative, and this is going to be positive. It will be the sign of the cofactors of all the elements of this 3 by 3 matrix. This is it. Easy, no? Now, if you understand what minor and cofactors of determinant are, now you can like the video and comment down whatever you don't understand. Thank you very much.